This lesson is on solving trigonometric equations. So far, we've looked at trigonometric equations that are identities, meaning that they are true for all values of the angle measure theta. Next, we're going to look at conditional equations involving trig functions, which means that they are only true for a countable set of values. So for instance, if I wanted to solve sine of theta equals the square root of 2 over 2, where theta is in quadrant 1. First off, you're going to want to have a unit circle handy here. So make sure, again, you can draw one out accurately and quickly for any test that you have to do. So to solve this equation, if I want to get theta by itself, I could take the arc sine of both sides of the equation. The sine and arc sine function cancel each other out. So this side just reduces down to theta, and now I'm just looking for the arc sine of the square root of 2 over 2. So I'm going to get my unit circle out and find out which angle measure, and I'm told that this is in quadrant 1, results in the sine being square root of 2 over 2. So there's a y value that's root 2 over 2, and the angle measure there is pi over 4. Now sometimes you might be asked to answer in terms of degrees, sometimes you might be asked to answer in terms of radians. Just follow the directions. But the default should always be radians if you're not told. Now certainly I didn't need to write this in terms of arc sine. If I'm looking for the angle measure theta that results in root 2 over 2, I could have gone straight to the unit circle and gotten the answer without using arc sine. But this would be the proper steps to walk through. Let's try a little bit more difficult problem. Solve 2 cosine theta minus 1 equals 0 on the interval from 0 to 2 pi. Okay, so now here's the situation. I am answering in terms of values along the interval from 0 to 2 pi. So I have to make sure all of my answers exist in that interval. Let me show you what I mean. Let's begin working with 2 cosine theta minus 1 equals 0. Well, I need to get theta by itself in order to solve for that angle measure. So the first thing that I'm going to do is just add 1 to both sides. So 2 cosine theta equals 1. Divide both sides by 2. Now I'm looking for where cosine theta is equal to 1/2, or theta is the arc cosine of 1/2. So in my unit circle, I'm looking to where x values are equal to 1/2. So there's one right there. Here is one sort of, but it's negative 1/2. So that's not going to be a possible answer there. So I'm going to leave that out. And if I continue all the way around, I've got down here in quadrant 4 a possibility as well. Now, since I'm answering in term on the interval from 0 to 2 pi, I need to provide both of those angle measures. So theta could be equal to pi over 3, and theta could be equal to 5 pi over 3. I need to answer with all the angle measures that exist on the interval provided. So make sure you answer in that respect. Otherwise you might give too many answers, or you might give not enough answers to get the correct answer in the end. So make sure you're watching that. And also, since the interval here is provided in radians, my answer needs to be provided in radians. So that's a way that they tell you how they want the answer provided. Okay, here's a slightly more advanced example. Solve the quantity cotangent theta minus root 3 times the quantity 2 cosine theta plus root 3 equals 0 on the interval from 0 to pi. So this is basically a quadratic, but it's already factored. And so I have the ability to just take each one of these factors and set them separately equal to 0 and solve. So you might be given a problem like this, or you might be given a problem that is a quadratic involving trig functions that you need to factor first, and then set each factor equal to 0. But this has already been factored, so I'm just going to set equal to 0 and solve. Alright, so with the first equation I could say cotangent theta is equal to root 3. But that's not going to be the easiest way of solving this particular problem. I'm going to switch it into tangent. So I'm just going to invert both sides. So tangent of theta is equal to 1 over root 3. Okay, now in order to solve for that, let me pull up my unit circle. Now my unit circle doesn't have values of tangent listed. I have to just rely on the values of sine and cosine that are listed and divide them to get tangent values. But one thing, if you'll notice, is that the points that involve the square root of 3 are like 1/2 root 3 over 1/2 root 3 over 2, or root 3 over 2 1/2, something like that. So let's say, for instance, it is this particular point right here. Since tangent is sine over cosine, at this particular point, if I invert and multiply, the tangent would be root 3. So that's not what I'm looking for. I'm looking for the tangent to be the inverse of that. So this particular point right here is actually what I'm looking for. Alright, because in that case, if I took 1/2 over root 3 over 2, it would be 1/2 times 2 over root 3, which is 1 over root 3. So that's where tangent is equal to 1 over root 3. So you can kind of think of these things in terms of those common values of sine and cosine. So if you think of this as 1/2 over root 3 over 2, it'll help you finding these particular points a lot faster. Alright, so regardless, we have found one, and that's at pi over 6. And it says to find this on 0 to pi, so that would be from quadrants 1 or quadrants 2. Tangent is going to be negative in quadrant 2, so there's not going to be any of these in quadrant 2 that'll work. So this is my only solution on that particular interval. Okay, let's go on to the other. 2 cosine theta plus root 3 equals 0. So I'm going to subtract the square root of 3 from both sides and divide both sides by 2. So I'm looking to where the cosine of theta is equal to negative root 3 over 2. So that's the x value involved on the intervals from 0 to pi. So that's it right there. So theta in this particular case could be 5 pi over 6. And that's my answer for that one. Next up, solve 2 cosine squared theta plus cosine theta minus 1 equals 0 on the interval from 0 to 0 degrees to 360 degrees. So this is on the interval that's one full rotation of the unit circle, but the answer is going to be in degrees rather than in radians. To begin, notice that I have a quadratic. Oops, I need a plus there. And in order to solve this, I need to get it as linear factors so that I can set each linear factor equal to 0. So I need to try and factor this thing. And it's perfectly fine to factor with a trig function involved, because you're looking for two things first that multiply to cosine squared theta. So 2 cosine theta and cosine theta are the only two things that would work here. Two things that multiply to 1 would just be 1 and 1, which needed to be negative 1. So one's got to be positive, one's got to be negative. But the other thing is I need that middle term to work out. So this one right here needs to be positive, and that one needs to be negative. The reason I know that is if I multiply these two together, I get negative cosine theta. If I multiply these two together, I get 2 cosine theta. When I add those two together, it results in just cosine theta, which is my middle term. So this is the correct factorization. If you're uncomfortable factoring with the trig functions, another thing that you could do, a little trick from college algebra, let u equal cosine theta and then substitute. So you would have 2u squared plus u minus 1 equals 0. Then you would be factoring without the cosine involved, but just remember in the end you would have to substitute back in. Regardless how you get to this particular point, this is where you need to end up. And the next thing that you need to do is set each of these equal to 0 and solve. So 2 cosine theta minus 1 equals 0, and cosine theta plus 1 equals 0. So 2 cosine theta equals 1, or cosine theta equals 1/2. And over here, cosine theta equals negative 1. Now to figure out these angle measures, I'm going to get the unit circle out and just find out where these things qualify. So on the interval from 0 to 360, I'm looking for where cosine, which is the x-coordinate of these points, is 1/2. So there's one right there at 60 degrees. And going on around, I don't find another one until I get to here, which is at 300 degrees. So those are the two values from 0 to 360 that qualify. Now, for cosine theta equals negative 1. So the only time cosine theta equals negative 1 is right here at 180 degrees. So my equation here has 3 different answers on the interval from 0 to 360 degrees. And these are the 3. Next up, solve 2 tangent x sine x minus tangent x equals 0 on the interval from 0 to 2 pi. So to do this, I would notice first that there's a common factor of tangent in both terms. So factor out the tangent, and that will leave you with this. Tangent x times the quantity 2 sine x minus 1 equals 0. Now, that means that tangent of x is equal to 0, or 2 sine x minus 1 is equal to 0. So let me solve. Tangent x is ready to go. Let me get sine x by itself. So this would be 2 sine x equals 1, or sine x equals 1/2. Get out my unit circle and see where things qualify. So tangent is going to be 0 whenever sine is equal to 0. So I'm looking for where y coordinates are 0. So there's one, and there's another. Those are the only two. I'm answering from 0 to 2 pi. Both of those are on that interval. So x could be 0 or x could be pi. Now I'm also looking to where sine of x is equal to 1/2. So the y values are equal to positive 1/2. So those are the two right there at pi over 6 and 5 pi over 6. Solve 2 sine 2x equals 3 on the interval from 0 to 2 pi. Alright, so I'm solving a double angle here. And in order to solve this, it's a little bit easier than you might think. So students' reaction most of the time is to take sine 2x and replace it with 2 sine x cosine x, which is not wrong, but it doesn't really necessarily get you closer to an answer. So let me show you what you should do. Just leave it as a double angle. So 2 sine 2x equals root 3. And divide both sides by 2. So sine 2x equals the square root of 3 over 2. I'm not going to leave it here though. I'm going to continue on. I'm going to take the arc sine of both sides. So if I take the arc sine of sine 2x equals the arc sine of root 3 over 2, sine and arc sine cancel each other out. So this just becomes 2x equals the arc sine of root 3 over 2. Or x is equal to the arc sine root 3 over 2 divided by 2. So our job next is to figure out what angle measures qualify for the arc sine being root 3 over 2. So to get those, sine is root 3 over 2 here at pi over 3. But it's going to be divided by 2. And then root 3 over 2 again at 2 pi over 3. But it's going to be divided by 2. And then those are the only answers from 0 to 2 pi. Now, let's go ahead and divide and see what happens. So when I divide pi over 3 by 2, it's the same thing as multiplying by a half. So this becomes pi over 6. And then the other answer is 2 pi over 3. When I divide this by 2, it's the same thing as multiplying by a half. The 2's cancel, so I get pi over 3. So this isn't quite the end of the problem here. We have to kind of take into account all the different possible values that arc sine could be here. So here's how I like to think of it. So let me go back up to our interval. So the original interval is 0 to 2 pi, which means all my answers for x have to be between 0 and 2 pi. Now, I'm not answering for just x, I'm answering for 2x, which is double that. So I'm going to multiply everything through here by 2 to get 0 is less than 2x is less than 4 pi, which is 2 rotations of the unit circle. So what that means is, so the pi over 6 and pi over 3 that I've solved are kind of like the root solutions. The rest of the solutions are just further rotations. And so I can find those basically by rotating values. So here's what I'm going to do. I'm going to bring up my unit circle again. And I'm going to say, okay, so my new values 2x are on 0 to 4 pi. So I'm going to have root 3 and 2 pi over 3. Those are my two answers from 0 to 2 pi. But since I can do two rotations, then I can also have pi over 3 plus 2 pi and 2 pi over 3 plus 2 pi. So just another rotation. So this would be 2 pi, 6 pi over 3, so 7 pi over 3. And 2 pi would be the same thing as, again, 6 pi over 3. 6 pi plus 2 pi would be 8 pi over 3. So pi over 3 is just coterminal with 7 pi over 3. 2 pi over 3 is just coterminal with 8 pi over 3. But since my interval for 2x is from 0 to 4 pi, I have to include those two angles as rotations. Which means my final answers are going to be pi over 3 divided by 2, 2 pi over 3 divided by 2, 7 pi over 3 divided by 2, and finally 8 pi over 3 divided by 2, which is, as we found, pi over 6, pi over 3 for the first two. For 7 pi over 3, it would be 7 pi over 6. And for 8 pi over 3, it would be 8 pi over 6 initially, or 4 pi over 3. Notice that these original angles are on the interval from 0 to 4 pi. These last angles right here are on the interval all from 0 to 2 pi. So it's tricky, but it's a whole lot easier than changing that into 2 sine x cosine x and trying to solve that way. Lastly, solve the square root of 3 tangent x over 2 equals -1 on the interval from 0 to 360 degrees. All right, first things first, let's solve for tangent x over 2. So all I need to do is divide both sides by the square root of 3. Now, we're not going to change this into a half angle identity. We're just going to leave it as is. But I'm going to take the arctangent of both sides. So x over 2 is equal to the arctangent of -1 over root 3. Now, before I finish this off, I'm going to figure out what angle measures are going to work here. So, again, same argument as I made in the last example. 0 to 360 is the interval from 0 less than or equal to x less than 360 degrees. But now I'm looking for a half angle measure, so multiply everything by a half. So the interval that I'm looking for right now for x over 2, which is what I'm solving for, is on the interval from 0 to 180. So I'm looking for the angle measures for which tangent is -1 over root 3 from 0 to 180. So it's going to be in quadrant 2 because it is negative, and I'm going to need the sine to be 1/2 and the cosine to be root 3 over 2 to get this -1 over root 3. So sine is 1/2, cosine is -root 3 over 2. To show you why that is, when you invert and multiply, we end up with -1 over root 3. So that's the correct value that we want. It turns out there's only one of these. So that is 150 degrees. So there's only one answer on the interval from 0 to 3 on this interval. Now, to expand that, we just need to double this. So I'm going to multiply both sides by 2. So x equals 300 degrees. So this is the only angle measure on the interval from 0 to 360 that I can divide by 2 and end up with a tangent of -1/3.